Okay, so we're starting ellipses today. The formal definition of an ellipse, and by the way, I'm apologizing now. I'm going to go pretty quick because I don't want this video to be really big or really long, rather, because the files get really huge and they take a long time to upload. So feel free, pause, replay, do whatever you need to do to write your notes down and get what you need. Okay, so a formal definition of an ellipse. All right, so with a parabola, we had all the points that were equidistant from a focus point and a directrix line. Okay, so now we have two foci, that is the plural of focus, and the ellipse is all of the points that are where you basically check the distance to their foci, to both foci, and you add those distances together. Okay, and the sum, so their sums are all equal. And we'll get more into that on Friday. We'll do the paper folding and we'll go outside and we'll do the chalk definition so you can actually see how they're created and equidistant from two foci. But for right now, this is basically, it's the formal definition. Okay, so pieces that we need to know. All right, so we have some specific vocabulary that we need. You already know what a vertex is. So I need you to understand something. In a parabola, we also call the vertex the center. And in a, what do you want to call it? In a ellipse, the vertex is not the center. HK is the center, but the vertex is a point that is not at that same place. Okay, so a vertex is basically the endpoint on the long direction of a ellipse, because it's stretched like a circle stretched in one direction, so it's longer one way than it is another. You did call it an oval when you were in like grade school. Focus is the same as it was in a vertex. It creates curve. It actually causes this shape to not be a circle anymore, to make it into an ellipse. Okay, so the covertex is the endpoint point on the short direction. Okay. And then we have the major and minor axis. The major axis is the long length, and it is the full length from vertex to vertex. Okay, and then the minor axis is the short length, and we're going to get a picture of this. And this is co-vertex to co-vertex. Okay. So again, major vocabulary that you need, and then again, pause whatever you need to do to fill this in, and then the actual picture of the ellipse. Okay, so obviously, like a parabola, it can go horizontally or vertically. All right, this is a horizontal one. We know it's horizontal because the vertices are on the long length, the x length, is going that way. And I do want you to draw it, and I do need you to label specifically A, B, and C. Okay. If you can tell, A is the distance from the center to the vertex. B is the distance from the center to the co-vertex. And C is the distance from the center to the focus. Okay. And remember that C is what causes the shape to go from being a circle. So imagine like you take the center of a circle and drag a point out from the center, out going in like either the horizontal or the vertical. It's going to stretch it that way. Okay. Now, obviously, again, this is horizontal. It works the same way if it's flipped over and it's vertical. And in fact, I'm going to do that real quick, just so you can see. It can go vertically as well. And that means that, the vertices would be on the top and the bottom. Those would still be the A length. The B would still be to the co-vertex. C would still be to the focus. So it can be drawn vertically or horizontally, just so you know. All right, these are the equations. And again, one for horizontal and one for vertical. The only difference, I'm hoping you can see this, is that the A, the long length, is, under the X variable, which means it's been stretched more along the X. And here the A, which is again your vertex, is under the Y. So it's been stretched along the Y axis. Okay, so horizontal and vertical. And then this is an equation you absolutely have to have because we are actually going to be solving with it. It's similar to the Pythagorean theorem. It's just not in the same order. And the reason it's not, again, taking a look at the picture, A always has to be the largest measurement. Okay, but B squared plus C squared do end up equaling A squared. Very important. We're actually going to work with that when we start solving for and writing equations. So very similar to the Pythagorean theorem. And again, I'm going to go pretty quick. Pause, replay, do whatever you need to do. I'm trying to get the file to where it's not so huge. Okay, so how to write an equation for an ellipse. So again, same thing we had with a parabola. You have to determine if it is going to be horizontal or vertical. And in this case, it's obviously vertical, going up and down, so that you know which function you're going to write. Okay, so if it's vertical, that means the bigger number basically goes up underneath the y value. And then we're going to just count squares if it's already graphed. And if you're given information, then you're going to graph that information on a piece of graph paper and then count squares. So my center, which has to be at the very middle of my vertices and co-vertices, in this case is 0, 0. Okay, so that's my H and K right there. And then I'm just going to count squares to figure out what my A length and what my B length is. Okay, my A is 5 squares. My B is 2 squares. Now, we don't need the getting the C formula right now. Take a look again. That is not something that you need. Like, you don't need to have C out of your equation, but sometimes you get the foci, the C length, and you have to go backwards and solve. So to write the equation, we need H, K, A, and B. That's it. Please note there is always a 1 on the end of these equations. They must stay there. Okay, so all we ever need is H, K, A, and B. That's it. Okay, so once we have those 4 pieces, we can kind of just plug it in like we did with the parabolas when we had H, K, and P. Okay, so H and K are 0, 0. A is 5. B is 2. It's vertical, so the big number goes under the Y. So in this case, since the vertex is 0, right, you can write x minus 0 squared, or you could just write x squared, right? Doesn't matter. And then y minus 0 squared. And then how far we stretched along the x, 2. 2 squared is 4. Along the y, 5. 5 squared is 25. Yes, you do really need to actually write out the squared terms. Don't leave them as 2 squared and 5 squared. Equals 1. And then you've written the equation for that ellipse. Okay, so not going to do another one just because it's, it's another one that's at 0. But if you wanted to, as far as like the final thing for this would be x squared over 1, 2, 3, 4, 5, 6, 7 over 49. And then y squared over 9 equals 1. That would be the finished equation for that. Okay, so now let's actually get a little bit more interesting where it's not centered at 0. So now we need to find the center, which again is just in the middle of all of your vertices and co-vertices, dead center of that. So it's actually pretty easy to pick out. So there is my center, and that is the point 3, 1. So you have your H and K. Okay, and then it's stretched more along the X. 1, 2, 3, 4, 5, 6, 7. So A is 7. And B is 4. Okay, and it is a horizontal one, so the bigger number goes under X. Okay, and remember that we always change those signs. Just as a reminder, see, these are always already a minus. So you have to change those signs in order to actually get your equation written correctly. So x minus 3 squared over 7 squared, which is 49. Okay, plus y minus 1 squared over 16 equals 1. Okay, so given a graph, it's usually not all that difficult to write them because all you're doing is counting squares. So let's move on to something a little bit harder where you're actually given the information. You are going to need to grab some graph paper today because writing this information down is not enough. You do need to graph it. Okay, as much as some of you might be rolling your eyes, I hate graphing. I can show you on Friday that there are some shortcuts to do this algebraically, but it really just depends on how well you can visualize. So, all right, so the center is at 2, 3. So I already have H and K. So 2, 3, right there. Okay. The major axis. Okay, remember the major axis goes from vertex to vertex, and they're telling you it is vertical and it is 10 units long. Okay, that does not mean A is 10. It means A is actually 5 because the entire vertical axis has to be 10 units long. So that means 5 up and 5 down, right? So there would be your vertices, right? So we know A is 5. And we have our center. And we also know now that this thing is vertical because it said the major axis was vertical. Okay, and we have our center point. Okay, and then it says that the minor axis is 6 units long. So same goes, the whole thing has to be 6. That must mean that it's 3 in each direction. So B is 3. Okay, so I have everything that I need in order to write an equation. I now know it's vertical, which again, just means that the bigger number is going to go onto the y. So x minus 2 squared over 9 plus y minus 3 squared over 25. And again, do not forget the equals 1 at the end. If you don't put a 1, then this is not an equation, it's an expression and it won't graph. You can prove it to yourself by trying to put it in Desmos without putting the 1 on the end. It ain't working. All right. So hardest for last always, because the standard always says that you're supposed to be able to write the equations given the foci. Okay. So the foci are at 4, 7 and negative 6, 7. So start by graphing those. 4, 4, 5, 6, 4, 7 and negative 6, 7. 2, 3, 4, 5, 6 right here. Okay, so please remember these things are symmetrical, which means the center has to be literally the midpoint between these two things. Okay, and we did this when we were doing absolute value stuff and complex numbers. All you're doing is counting squares, right? I should have 10 squares between these, which means 5 squares right there should be my center. And that is negative 1, 7. So I already have my H and K. If my foci are going to the left and the right, that means that my whole ellipse is horizontal, right? Because the foci are the ones that stretch the graph out to actually, go in that direction. So that means that it is a horizontal, right? And I have a C value at this point. Okay, the C is right here. It's the distance between there, and the C value is 5. Okay, they're telling me that the minor axis is 8 units long. We just talked about that as far as what that means. That means I'm going to go 4 in either direction. 1, 2, 3, 4. 1, 2, 3, off the chart, 4. But that at least gives me B. Okay, so there's where this other equation comes in, where you are going to be solving for A using this information, right? So A squared is B squared plus C squared. So 4 squared plus 5 squared is going to give me the A squared. Now, I told y'all a couple times about this on the parabolas, like when you were solving and you were trying to solve for what P was, you didn't actually have to divide it all the way out if all you're doing is writing the equation. Same goes here. I don't want to square root A unless I'm trying to pick pieces out. If all I want to do is write the equation, don't do that to yourself, because that is just going to be annoying as mess, trying to get the decimals and then square it back out. Okay, just leave it as A squared. That's how you write the equation anyway. So that's just going to be 41. Okay, and yeah, I know that's not going to come out as an even number. Big deal. They don't have to. Okay, so let's go ahead and write the equation. It's horizontal. So x plus 1 squared over 41, because that's our A, because it is horizontal, okay, plus, all right, and then b minus 7, or no, not b, what am I thinking? Y minus 7, let's try that again. Y minus 7 squared, okay, over, well, whatever b is, 16, okay, equals 1. And then we're done. And the equation's written. And again, I'm just trying to make this short. Pause it, replay it, do whatever you need to do so that you get all the examples that you need. And then you can go back and do through the work. Okay, so I'll be on remind. So send me a message if you have any questions.